Let's continue lesson 7.2.6 with problem 7-105, right trapezoids. Now here we're dealing with a new quadrilateral, a trapezoid. And so before we go any farther, let's add that to our toolkit. The definition of a trapezoid is a quadrilateral with one pair of parallel sides. So let's add that to our toolkit. And then let's show the definition on the shape itself by adding parallel arrows. So at this point, you're going to read through the introduction and try and complete A and B. But again, I would encourage you to use the link in the description to open up the ebook if you haven't already, because when you use the ebook, these vocabulary terms are linked so you can access the definition. And so as you do this, click that link to view the definition of consecutive angles of a polygon. Hit pause and then play when you're ready. So by now, hopefully you read through this in the ebook. You clicked this link and you saw that consecutive angles of a polygon are defined by what's written in this box. And so A asks us to explore this quadrilateral, and based on the fact that these consecutive angles are right angles, what must be true for sides AB and DC? Well, because we're dealing with a right trapezoid, as they say, even though we haven't proven this is a trapezoid, I'm going to guess, based on the definition of a trapezoid, that side AB is parallel to side DC. That's my conjecture. And so B asks us to write our conjecture in a conditional statement, that is, an if-then form. So we'll say if a quadrilateral has two consecutive right angles, then it is a trapezoid. On to letter C. Letter C asks us to prove our conjecture and to use a two-column proof. And so we're going to do our work down here. Remember, a two-column proof is really no different than a flow chart. It shows all the same information, it's just arranged differently. So don't be intimidated by it. All right, at this point, I want you to see and think about how you would prove that those sides are parallel. If you look back at your work in problem 7-72, we proved that opposite sides of a rectangle are parallel. Look back at that work and see if we can use the same argument here. As always, press pause, look back at that work, and then play when you're ready. So hopefully you saw in that problem that we used the concept that if same side interior angles are supplementary, then lines are parallel. That's the same side interior angles converse. So do we have that here? Yes, we do. These are same side interior angles, and since they're both 90 degrees, they are supplementary. They equal 180. Okay, so now we just have to show that condition that we have supplementary same side interior angles, and then we can conclude that opposite sides are parallel. Okay, so statement 1, we can say angle A and angle B are same side interior angles. We could say given, but we're really going to use the definition of same side interior angles being two consecutive angles formed by a transversal and two lines. Now, think about what our second statement might be. We can say angle A and B are right angles. What would our reason for that be? How did we know those were right angles? That's right, that was given to us. Statement and reason 3. Angle A and angle B are supplementary angles. How do we know angle A and angle B are supplementary? Think about what reason you would write to go with statement 3. Hopefully you wrote or thought of something like all right angles, or not all. We could say two right angles will always be supplementary, because 90 plus 90 will always equal 180. Something like that. If you wrote 90 plus 90 always equals 180, that's fine as well. And then now we can conclude that side AB is parallel to side DC because the same side interior angles converse, which we wrote right here. If same side interior angles are supplementary, then lines are parallel. That's the same side interior angles converse. And so instead of writing out that whole statement, we just write same side interior angles converse. And then 5, ABCD is a trapezoid. Why? Hopefully you said the definition of a trapezoid, which is a quadrilateral with a pair of parallel sides. So now let's go to our toolkit and add the definition of a right trapezoid, which would be a trapezoid with two consecutive right angles. And we can add our parallel arrows to that because we just proved if those two angles are 90-degree angles, then opposite sides are parallel because of the same side interior angles converse.